guys, so this video will be another video in the series of basic electronic components. So previously, diniscuss natin yung resistor and capacitors. So another basic electronic component is what we call diode. So we'll discuss syempre yung symbol ng diode, then how diode works, basic function ng diode, and also what we call the PN junction. Then we'll also discuss the diode biasing, the reverse breakdown voltage of diode, and I'll give the most common application of diode. Okay, so we'll discuss that later on. So diode, so ano nga ba yung pinaka-basic function ng diode? So diode basically conducts current in one direction. At dahil sa basic function ng diode na ito, nagkaroon siya ng several applications sa electronics. So, isa sa mga pinaka-importante ng electronic component is ang diode, and with its basic function of conducting current in one direction, marami siyang pwedeng paggamitan sa electronics. Actually, the word diode is derived from di-anode, meaning dalawang electrode. So, later on, we'll discuss yung structure ng diode, and katulad ng binanggit ko nga, yung tinatawag nating PN junction. But before that, I want to show you the symbol ng diode sa schematic diagrams. So, basically, ito ang symbol ng diode sa schematic diagrams. Meron tayong triangle, and sa tip na ito, sa dulong tip is merong slash or may line. And yung sa part na may line, ito yung negative. And sa kabila yung positive, since diode is a two-terminal device with polarity. So, meron tayong positive and negative. Unlike yung na-discuss nating resistor na wala namang polarity. So, mostly naman ng other electronic components natin ay may polarity. So, palatandaan sa symbol ng diode na yung sa may line or slash, yung negative side. So, sa baba niya yung actual na itsura ng diode, usual or typical diode na ginagamit natin. Although, may iba't iba syempreng types ang diode. Although, I won't be able to cover yung different types of diode. Maybe I'll have a separate one to discuss each, okay? So, now that we've seen the schematic symbol of diode, now let's go to PN junction na mention natin. Before we can understand yung function or yung how diode works, let's first discuss PN junction. Basic fundamental idea or concept when it comes to diode. So, PN junction, from the word junction. So, P at N. So, itong PN junction na to is composed of what we call the P-type material and the N-type material. Kaya nga siya naka-form ng junction. So, pinagsama, pinag-combine, pinagdikit yung P-type tsaka N-type material. Ngayon, ano ba tong P-type tsaka N-type material na to? So, ito basically yung structure sa loob ng typical diode. Yung isang PN junction. So, P-type and N-type. Ang P-type and N-type material ay basically semiconductor material. Okay? Semiconductor material na duman sa process na tinatawag na doping. So, what is doping nga ba? So, sa diode kasi ang ginagamit na doping is substitutional doping. Meron kasing interstitial, although hindi natin didiscuss yan. So, tandaan nyo lang sa diode is it's substitutional doping. So, doping is when we introduce impurity sa ating material. For what reason? Usually, ginagawa natin ito sa semiconductor. For example, ang silicon. Silicon is the most common na element na ginagamit as semiconductor. Semiconductor, from the word itself, semiconductor, meaning it could be an insulator or it could be a conductor. In its pure state ng silicon, without impurities, without the process of doping yet, ang silicon ay actually insulator. So, insulator siya. But, if we introduce impurities through the process of doping, na sinasabi natin substitutional doping, so, when we introduce impurities, doon nagkakaroon ng characteristic itong silicon to become a conductor. That's why it's called a semiconductor. The element could be an insulator or a conductor. It's an insulator if it's in its pure state or pure form. Now, when we introduce impurities through the process of doping, it becomes a conductor. So, first question is, bakit silicon ang isa sa mga common na ginagamit as semiconductor? Aside from silicon, germanium is another element that can be used as a semiconductor, although silicon is more widely used or more common. So why? Because silicon, if you were going to look at its atomic structure, so I have a picture here. Although hindi na natin masyadong i-discuss yung topics ng atom and everything, but silicon kasi, when you look at its atomic structure, it has 4 valence electrons in its outer orbit. Okay? Ngayon, ano nga ba yung valence electrons? So, valence electrons, kasi ito yung responsible sa atomic structure ng atom. Kasi, yung valence electrons, yung nagbaband sa other atoms. So, sa example natin sa silicon, it forms a covalent bonding with the other atoms. So, yung nagko-covalent bonding, yung mga valence electrons, okay? Now, because of the structure of silicon, in which it has 4 valence electrons, nandun siya sa stable na state. Okay? As stable na state, wherein yung bawat 4 valence electrons, yung bawat valence electron na yun, nag-prepare in a covalent bonding dun sa other atoms. That makes the atomic structure of silicon stable. So, pag 4 yung valence electrons niya, nandun siya sa stable na state. Ngayon, itong valence electron to, hindi pa ito yung tinatawag natin na free electrons, which is responsible dun sa flow of electrons kapag may kuryente na. Kasi, wala pa naman tayong ina-apply ng external energy. So, valence electrons is not exactly the same as free electrons kasi when we talk about free electrons, ito yung kapag nasa conduction band na tayo, kapag na-overcome natin yung energy gap to jump from the valence band to the conduction band. So, may energy gap kasi pa dun in between sa valence band and conduction band. So, pag nandun na tayo sa conduction band, doon na natin siya tatawagin ng free electrons. But, for now, it's called valence electrons. When we're talking about the atomic structure and when we're not yet talking about external energy applied. Ngayon, ang silicon nasa stable state because it has 4 valence electrons, which forms perfect covalent band, which makes it a good insulator in its pure state. Now, if you're going to use it as a conductor, dun na papasok yung process ng doping where we introduce impurities. So, how do we do it? Okay? So, by the way, ito nga pala yung picture ng representation ng atomic structure ng silicon forming a perfect covalent bond. Okay? So, dun tayo sa doping. Sa doping kasi, we can create 2 types of material. Yung pinag-uusapan natin kanina, P-type and N-type. So, what is the difference between these two? And sa P-type and N-type na to, meron tayong pag-uusapan na pentavalent material tsaka trivalent. Okay? First, let's go dun sa N-type. Sa N-doping. Sa N-doping, what we want to achieve is an N-type material, meaning negative type of material yung ating gustong achieve. Meaning may excess ng electron kasi kapag nasa pure state siya, neutral siya. Now, if we introduce doping, we can create either positive type or negative type ng material. So doon naman tayo sa N-type. Ang example natin is silicon, di ba yung semicon natin? Then, if we want to create an N-type material, we are going to use what we call the pentavalent material. Penta, from its word, penta means 5, so ibig sabihin lang ito, itong material na to, meron siyang 5 valence electron. At ang example ng ating pentavalent material is what we call phosphorus. So there are other pentavalent elements, but one of them is in doping, and type doping is what we call phosphorus. So if we're going to look at this picture, so diba nga perfect covalent bonding and structure ng silicon. Now if we were going to substitute phosphorus into one of the atoms of the silicon element, substitutional doping na, we're going to substitute it with phosphorus, which has 5 valence electrons. So yung 4 valence electrons ng phosphorus mag-perform ng covalent bond with the other silicon atoms. So may matitirang isang valence electron from phosphorus na walang partner or walang covalent bonding. That's why nagkakaroon tayo ng excess electron. And because of this excess electron, nagiging N-type material. So, meron tayong N-type material, no? So, that is what we call N-type na doping. Pentavalent material ang gagamitin, meaning may 5 valence electrons. Okay? Now, if we're going to talk about naman P-type material or P-type doping, what we're going to use naman is what we call the trivalent material. Trivalent, so tatlo, meaning may tatlong valence electron tong element na to. So, in our example, we use boron. So, meron tayong silicon structure na may perfect covalent bonding. Then, we're going to substitute boron into one of the silicon atoms. Then, since tatlan lang yung valence electron niya, yung tatlong yun mag-prepare into covalent bond with other silicon atoms. Ngunit may isang kulang. So, para magkakaroon tayo ng, since yung isa na silicon atom ay isang valence electron ng silicon atom, wala siya magiging partner kasi tatlo lang yung valence electron ng boron. So, magkakaroon tayo ng excess hole. And we know ang representation ng hole is positive. Okay? So, kung kanina excess electron, ngayon naman excess hole. Meaning may lack ng electron. So, yun naman yung process ng paggawa ng P-type material or P-type doping. So, now we have the P-type material, the N-type material. Now, we can create the PN junction. So, pagkasamahin natin to form a junction, yung P-type tsaka N-type material. Okay, so this is the basic construction of a diode, typical diode. So, yun ang basically what's inside a diode. P-type and N-type material forming a junction. Now that we know na yung basically kung anong structure sa loob ng diode, we can now talk about diode biasing. So, diode biasing meaning yung how we apply external voltage to the diode para mag-operate siya either in the forward or in the reverse bias. So, sa diode biasing, meron tayong forward, tsaka meron tayong reverse bias. So, first, let's talk about forward bias. Kasi, di ba pinag-uusapan nga natin kanina, yung function ng diode, that it conducts current only in one direction. And that is when we forward bias a diode. So how do we forward bias a diode? A diode is forward bias when we connect a positive voltage supply to the p-type material. O yung positive side ng diode. Then, we connect a negative voltage supply sa negative side or sa n-type side ng diode. So, if you have a battery, may positive and negative din yun. So, positive ng battery sa positive ng diode, negative ng battery, negative ng diode. So, sa ganitong setup, naka-forward bias ang diode. Meaning, current can flow through the diode. Meaning, the diode will allow the current to flow or to pass through it. So, sa biasing na to, yung tinatawag na depletion region in between sa p-type and n-type material kasi numinipis. And sa pagnipis nito, diode can conduct. Diode can conduct the current. Or current can flow through the diode. Kasi, when we forward bias it, nagkakaroon ng recombination of holes and electrons dito sa junction na to. So, bakit nga ba? Kasi we know naman, di ba, na ang opposite charges attract and like charges repel. We know that from basic chemistry. So, yung positive natin sa supply, then yung positive dun sa p-type material. So, para sa positive, meaning it will repel each other. So, because of this repelling action, mapupush away yung positive or yung holes sa p-type away dun sa positive supply natin. And sa other side naman, negative to negative, yung electrons natin sa n-type material, ipupush away din or magre-repel din dun sa negative supply natin. So, itutulak palayo dun sa supply, which will cause these holes in electrons to meet and combine dun sa may junction. So, nagkakaroon ng recombination ng holes and electrons sa ating junction. Okay? Ninipis yung depletion region. Okay? Ninipis yung depletion region, current will flow. Ngayon naman, let's talk about the reverse bias. So, reverse bias, kabaliktaran naman yung gagawin natin pagkabit sa supply. Yung p-type nakakonect sa negative and yung n-type or negative side ng diode nakakonect sa positive naman ng supply. And in this biasing or in reverse biasing, diode will not conduct current. Current cannot pass through the diode. So, dito naman sa reverse biasing, since opposite charges yung pinag-connect natin, positive to negative, n-type to positive, nagkakaroon naman ng attraction. So, yung holes, which is yung gray, holes natin sa p-type, na-attract dun sa negative ng ating supply. So, pag umalis tong holes na to, basically, nagkakaroon ng so, mababawasan yung holes. So, logically, parang nagkakaroon ng excess electron kapag nawala yung hole. And sa kabila naman, kapag inattract ng positive supply yung mga electrons ng n-type, yung orange. So, pag umalis yung electrons, basically, nagkakaroon ng hole. So, sa n-type, dumadami yung hole. Sa p-type, dumadami yung electron. Which makes the depletion region in the junction of the diode wider. So, because of this, parang ina-attract naman papunta sa supply. Nagkakaroon ng wide depletion region sa ating junction. And because of this, current cannot flow through the diode. So, nasa reverse bias tayo or nasa condition tayo of no current flow. So, anong nangyayari? Yung sa P-type material, dumadami yung electrons. Sa N-type material, dumadami yung holes. Ang majority carrier natin ng current sa P-type is holes. At sa N-type naman is electrons. So, basically, nagkakaroon tayo ng lack of majority carriers. That's why current cannot flow because of the lack of the majority carriers. So, basically, meron pa ring flow na maliit because of the minority carriers. So, sa P-type kasi, ang majority carrier is holes. Ang minority niya, electrons. Sa N-type, ang majority carrier niya is electrons, while ang minority carrier niya is holes. So, basically, ang flow na lang kapag reverse bias is very, very small due to minority carrier. Okay? Ngayon, alam na natin yung forward bias, alam na natin yung reverse bias. Basically, naiintindihan na natin how current will flow or not flow through a diode. And by the way, meron tayong tinatawag na threshold voltage for diode. Before siya mag-conduct, kailangan niya ma-overcome muna yung tinatawag na threshold voltage. For silicon, it is 0.7 volts, and for germanium, it is 0.4 volts. So, kahit nakakabit na siya in the forward bias, if yung supply voltage natin is less than sa ating threshold voltage, hindi pa rin siya magkakonduct. So dapat ma-overcome niya muna yun para mag-conduct yung current. Okay? Sa forward bias. And meron din naman tayong tinatawag na reverse breakdown voltage. So, pag naka-reverse bias yung ating diode, diba hindi mag-flow yung majority carrier ng current. Walang flow ng current. Pero, kapag na-reach niya yung tinatawag na reverse breakdown voltage, biglang magkakaroon ng flow of current na mataas. Magkakaroon ng rapid rise of the flow of current. Kapag nagpasan niya or naabot niya yung reverse breakdown voltage. Okay? So, ayun natin umabot dito. Although, there is a diode that we call Zener diode, kung saan ang normal operation niya is nasa region na itong ng reverse breakdown. So, yun yung function ng Zener diode sa reverse breakdown na region. Although, we cannot discuss all the types of diode. It will be another video. Okay? So, lastly, what we're going to tackle is the most common application of diode, which is rectifier. So, maraming uses. Although, meron tayong tinatawag na full wave, half wave, full wave bridge. Yung full wave bridge is most commonly used sa power supply. So, rectifier. So, doon muna tayo sa half wave. So, kapag sinabi nating half wave rectifier, we only have one diode. Okay? And, bakit ba siya naging half wave rectifier? Kasi basically, ang nangyayari sa signal natin kapag lumabas na siya ng diode or nagiging output signal natin is nawawala yung half cycle, yung negative half cycle. Ang naiiwan yung positive half cycle. So, parang nahahati sa gitna, half wave. Ang natitira yung upper positive half ng cycle, ng wave. Bakit? Since alam naman natin, diba, na diode conducts current only in one direction. So, kung may AC tayo, dadaan sa diode, during the positive half cycle, naka-forward bias siya. So, magkakaroon tayo ng output signal. But, kapag nag-change polarity na yung ating input signal sa negative half cycle, magiging reverse bias na yung diode natin. Kasi, kung negative half cycle na, pag dumaan siya dun sa positive ng diode, reverse bias siya, diba? From reverse bias topic. So, mawawala yung negative half cycle. So, paglabas niya ng diode, ang matitira lang yung mga positive half cycle. So, parang nahahati sa kalahati or sa gitna yung input natin pagdating sa output. So, ito nga yung magiging itsura niya. Input signal natin, yung unang graph, then output. Pagdating ng output, wala na yung negative half cycle. Positive na lang natira. So, yan yung half-wave rectification na function ng diode. Okay. So, basically, discuss ko muna yung how half-wave and full-wave rectification works. And yung specific na uses, maybe in other videos. Ngayon, meron din tayong tinatawag na full-wave rectifier. Meron yung full-wave bridge. Later, discuss natin. Full-wave rectifier muna. So, sa full-wave rectifier naman, meron tayong dalawang diode. Meron tayong D1 and D2 at connected sa center top transformer. Okay, so ang nangyayari kasi dito, nagsasalit-salitan mag-conduct yung D1 at D2. So, bakit? Kasi, ang magko-conduct, either D1 o D2, ang magko-conduct ay kung anong diode naka-forward bias with respect sa center top. Okay? Again, so ang magko-conduct na diode at a time is kung anong diode ang naka-forward bias with respect sa center top point, which is C. So, explain natin. So, meron tayong AC input signal. May positive and negative half cycle. Okay? So, during the positive half cycle ng input ng AC natin, ang point A, sa picture point A, yung yellow na nakabilog, yung point A natin is positive with respect sa C. During the positive half cycle ng input, AC input, ang point A natin is positive with respect sa C. So, because of that, mako-forward bias yung diode 1 natin. Positive to positive, okay? Yung dito, hindi pa nagko-conduct. So, magko-conduct yung D1, current will flow through D1, papunta sa RL. Now, kapag nag-negative half cycle na yung AC input, yung point B, sa baba, nakabilog na dilaw, yung point B will be positive with respect sa point C. Take note, with respect sa point C. So, during the negative half cycle, point B is positive with respect to point C. Because of that, forward bias yung D2. So, naka-reverse bias na yung D1. At this time, D2 na ang mag-conduct. So, current will flow through D2, then to RL. So, ang output natin, resultant output waveform natin, is yung positive cycles lang nung D1 tsaka D2. So, parehas naman yung direction ng pasok ng current papunta sa RL. If you would notice, diba? Parehas yung pagpasok, direction ng pagpasok sa RL. So, sa output waveform, nasa positive half lang yung output natin. So, parang siyang nahati sa gitna. But, unlike ng half wave rectifier na parang bungi, dito, walang gap na ganun. Since, dun sa gap na yun, yung dito yung magkukonduct. Okay? So, that is one configuration ng full wave rectifier. Pero meron din tayong tinatawag na full wave bridge rectifier. So, in full wave bridge rectifier, 4 na diode naman yung ginagamit natin. Na parang naka-diamond. Katulad ng sa picture. So, ganyan yung pagkaka-placing ng diode in full wave bridge rectifier. So, paano naman? How does full wave bridge rectification works naman? So, in this example, we use 4 diode but we don't need to use the center top transformer anymore. Okay? So, dun tayo sa part ng AC diretso dun sa may full wave bridge diode rectifier. So AC yung ating input signal, no? So, pag nasa positive half cycle ng AC input, ang magko-conduct na diode o ang naka-forward bias na diode is yung mga nakapula. So, sila yung magkakonduct at this time. Yung dalawa is naka-reverse bias. Kasi nakaharap yung negative side nila, diba? Yung cathode nila. So, basically, ang magkakonduct yung mga pula. Okay? So, una, papasok yung current dun sa may diode sa bandang taas. Sa upper right. Then, lalabas papunta sa load. Then, from the load, pupunta dun sa may second diode na nasa nasa lower left. So, ganun. Then, from there, pabalik na dun sa supply. So, ganun yung flow ng current during the positive half cycle ng AC input. So, meron tayong sa output natin positive half cycle. Then, kapag nag-negative naman yung ating AC input, negative half cycle, eto naman, ang magkakonduct naman yung mga naka-blue. So, ang flow ng current is daan muna dun sa diode sa lower right, then papunta sa RL, then from RL, punta dun sa blue diode na nasa upper left, then back to the supply. So, ganun naman yung flow ng current kapag negative half cycle. So, sa positive at negative half cycle, nakakadaan yung current. Pero sa output, syempre, ang labas niya sa positive half cycles ng diode. So, parang natanggal ulit yung kalahati. Pero wala siyang bungi. Kasi yung sa unang half cycle, yung mga pula yung nagkakonduct. Then, sa pangalawa, yung mga blue. So, wala tayong gap. So, meron tayong full wave. So, yung may mga gap, yun yung half wave rectification. Sa full wave, meron tayong dalawang klase. Pwedeng dalawang diode dun center tap. Or, kahit wala na center tap, naka-bridge tayo. We can achieve full wave rectification. So, basically, that's how half wave and full wave rectification of diode works. So, marami ding application to. We cannot discuss all of those in this video. We'll have a separate video for that. Basically, pinaka-common na application or use ng diode is as a rectifier. So, here, you can see yung mga references ko. I will be putting it in the description if you want to read more. So, mga online resources. So, basically, ayun, no? We have discussed a symbol, PN junction, the doping, the creation of the P-type and the N-type material, the biasing of diode, and we've also talked about the reverse breakdown voltage, and the most common application, which is as a rectifier. So, sa other videos na siguro yung different types of diode, kasi may iba-iba rin, and medyo detailed discussion din. Then, yung mga specific examples ng rectifier will be in future videos. So, for now, we've had a basic familiarization of diode, the idea of the basic structure, how it's made, and the basic function, how it works, and basic application, how it's used. Okay? So, thank you, and see you in the next videos.